Alright, so next section, not very long. It's called the Factor Theorem and Remainder Theorem. Those are the two main ideas. And just some terminology. Roots. You're going to see that a lot in this unit. The roots of this equation, the roots of this polynomial. You basically just need to remember that this is synonymous with X-Intercepts, zeros. Okay, all this stuff means the same. Okay? So, for example, if I asked you, is negative 4 a root of the polynomial f of x equals x to the 4 minus 3x cubed minus x squared, what would happen, or what does it mean if negative 4 is a root of the polynomial? It's an x-intercept, so what does that mean if I plug it in? What's f of x the same thing as? What does y equal at the x-intercepts? 0. Right? So if you plug it in, you should get 0. Okay? So let's check it out. F of negative 4 has to equal 0. That's the question. If it's a root, it's got to equal 0. If I plug it in, negative 4 to the 4th power minus 3 times negative 4 to the 3rd power minus negative 4 squared is what it would look like. We want to know if this equals 0. This becomes 256 minus 3 times 64, which is, anybody? $192? 192, okay. Well, you got a minus. Oh, yes. A negative cubed is negative times a negative is positive. Good catch. So there's no way this is going to equal 0. Okay, so the answer is no. Another question. What are the roots of g of x if g of x equals x minus 5 squared times x plus 3 cubed? We'll keep it easy. What are the roots? Five and negative 3. Done. Does everybody see how we got that? Okay. In case you didn't, this is factored. Once you have it factored, you just set each factor equal to 0, right? Which gives us 5 and negative 3. By the way, how many times would x minus 5 show up in the, if you actually wrote it all out? Twice. How many times would you see x plus 3? 3 times. this is where I'm going to introduce a new word called multiplicity. It's the number of times I'll use my own terminology, the number of times you get a root. What I mean by that is, if x minus 5 is squared and you set each single factor equal to 0, how many times would 5 be a root? Twice. So we say that 5, so in this scenario, 5 has multiplicity 2. Bless you. Negative 3, you would get negative 3 how many times if you set each factor equal to 0? 3 times. So negative 3 has multiplicity of 3. Okay?
And you're just getting that from what it's...
Basically from the exponents. Well, if you saw x minus 5 squared and then later on down the road you had another x minus 5. You know what I mean? So you wouldn't say 5 has multiplicity of 2 and then also 1. It's going to be 3. Does that make sense?
Yeah.
Okay. Anybody lost or confused? Well, good. Okay. So let's get to the main point of the lesson. One of the two things we need to talk about is the remainder theorem. Which says that if a polynomial is divided by x minus r, the remainder is just f of r. A lot of times, really all you care about is whether there's a remainder or not. So rather than doing the entire division algorithm, if it's long division, synthetic isn't too bad, but if you have to do long division and you want to know if there's a remainder or not, this is pretty quick. So for example, if you have f of x equals 2x squared minus 3x plus 4, and let's say divided by x minus 1. And we don't care about the entire thing, we just want to know, is there a remainder, and if so, what is it? What could I do? According to the remainder theorem, if I'm dividing by x minus r, if I want to find the remainder, all I have to do is plug in r. So all I have to do is figure out f of what? Not f of x minus 1, f of 1. So this is just 2 times 1 minus 3 times 1 plus 4. 2 minus 3 plus 4 is 3. So 3 is the remainder. Yes?
Where did the 1 come from? Yeah. Where did that, was that a given x minus 1?
The 1 came from here.
Well, is that a given? Or
Oh, yeah, this is all given to you.
Oh, okay.
Yeah.
So would you just, let's say you get 1, you just say 0, that's equal.
I mean, look, if you don't remember this, it's not the end of the world. Could you just do the division and find the remainder? Yes. This one, however, factor theorem, pretty big deal. let f of x be a polynomial. Then f of r is going to equal 0 if and only if x minus r is a factor of f of x. We can add a little note to this. If I'm checking to see whether this divides f of x and I get 0 when I plug it in, what does that mean? What kind of remainder is there if I get 0 when I plug it in? There isn't one. Okay? This is the same as saying dividing by x minus r yields no remainder. Okay. So before we do the last two examples, because we're almost done with this. Yeah. Sure. You couldn't have waited?
No. I just, I just, 10 minutes.
Really?
I just said it. I don't know.
Are you going to do it all next year?
Yeah.
Okay. That's the condition I'm signing it with.
Okay. It just says anything that you've ever participated.
All right. Yep. Okay, let me ask you a question. So, see if you understand this or not.
You think he even knew what he had on his shirt? Like, you know how people just get random tattoos of Chinese?
He's a pretty smart kid. I'm sure he probably knows what it is. Yeah. Okay.
It's just,
If, so listen carefully. If I plug in 10 into some function, and I get 0 when I plug in 10, what does that mean?
well, that's the root.
Say that louder, John.
What did you say?
If I plug in 10 into some function, and when I do that, I get 0. What does that mean? No remainder when you divide by x minus 10, which also means that x minus 10 is a factor of that equation. Does that make sense? So let's skip all the middle work. If 3 is a root, that means x minus 3 has to be a factor. Do you guys understand?
Yeah.
Let me show you this way. Let's say f of x equals x squared minus 5x plus 6. Okay? You guys know how to factor that, right? What does it factor into? If I asked you to find the x-intercepts, which again are synonymous with zeros or roots, right? What would you do with these factors? Set them equal to 0. So that gives us x minus 3 equals 0, x minus 2 equals 0. So what is x? 3 and 2. So this is saying that 3 is a root and 2 is a root. So all we're doing is going backwards. If I know that x equals 3 and x equals 2 are intercepts or roots or zeros, I should be able to go backwards and say, well, that had to have come from a factor that looked like this. Right? Does that make sense? Okay. So, and let's pretend that we don't know what this looks like. If I know the x-intercepts are 2 and 3, and I know that this is a parabola, then we know it looks something like that, right? So not only can you look at a equation, factor it, get your roots from there, if you have a picture given to you, and you see that 2 is an intercept and 3 is an intercept, that means all of the above. If 2 is a 0, that means it's an x-intercept. If 3 is a 0, it means an x-intercept, which means that this is how it factors. Okay? So here's a quick example. Let's say f of x equals x cubed minus 5x plus 2. And we have the graph, and it looks something like this. And when we look at the graph, you all done? Okay, just put it in the bin. When we look at the graph, we see that it hits x equals 2. We can't really see what this number is. We can't really see exactly what that number is, but we're really darn sure that it crosses at x equals 2. So from the picture, what can we say? Yes, 2 is a root. What else does that mean? X minus 2 is a factor. And if it's a root, what happens when I divide x minus 2 into the original equation? It gives you, I couldn't hear, a remainder of 0. Does that make sense? So let's see what happens when I do that. Using synthetic division, I'm going to take x minus 2 and divide it into x cubed minus 5x plus 2. When I do synthetic, what do I put in the little box? 2. And then what do I write down? 1, 0, good. Negative 5, 2. Bring down the first number, we get 1. You multiply 1 with 2, 2, and then we just add when we're doing synthetic, right? So now we get 2. 2 times 2 is 4. Add them up. Negative 1. Negative 1 times 2 is negative 2. Add them up. 0. So, I mean, this confirms that we have a 0 remainder, right? More importantly, though, here's the quotient, right? So when I take this original polynomial and divide it by x minus 2, we know that x cubed minus 5x plus 2 equals the divisor. See how I'm just using that algorithm that we did a while back? Times the quotient. What is this written out as when you actually use x's? And if there's no remainder, we don't add anything there, right? So this is kind of a big deal because we may not have known how to solve for x when it was like this, but now that it's factored out, can I solve for x? We already know what answer this is, right? X equals 2. What do I do here? You do quadratic formula. I mean, if it factors, but it doesn't. So you do quadratic formula. You got x equals negative 2 plus or minus the square root of b squared. So 4 minus 4 times a times c all over 2 times a. So we get negative 2 plus or minus, this is going to be 8, right? So 2 root 2. Well, that's pretty easy. This is just what? Negative 1 plus or minus root 2. So we just figured out for our original picture We knew one of the answers was 2. We didn't know exactly what these two intercepts were, but using what we knew and using synthetic division, I was able to figure out the other piece of the polynomial, and then you can factor that or use quadratic formula. Does that make sense? How much time do I have?
1 minute.
Let's see how quick I can do this. Find remaining roots if 3 and negative 2 are roots of x to the 4 plus 2x cubed minus 7x squared minus 20x minus 12. You guys agree we don't know how to factor this, right?
Yeah.
But if 3 is a root, can I divide it in here and get a 0 remainder? Let's see what happens. Bring down the 1. 1 times 3? 3. Add them up.
I have a question.
Yes.
Is the number of roots the number of the highest exponent?
We're going to get to that. And typically, yes.
Or wasn't it opposite to the X-intercept, so it can be up to that, but it's not necessarily that.
Yeah. Now, here's what I wanted to say. No remainder, right? This represents a cubic instead of a quartic now. What you can do to find the other two answers is use negative 2, take what numbers you got left, repeat the process, and now you're going to get what kind of equation is this? It's a quadratic. Those are the ones you know how to deal with, right? So if you factor this, x squared plus 3x plus 2, sorry guys, thanks for sticking around for this extra minute. You factor this into x plus 2, x plus 1, now you know what your other answers are. What do we get? Negative 2, which it's just repeated root, but then negative 1 is the one we didn't know about. I know that was quick. We'll go through it again tomorrow if we have to. Thanks.
I don't understand
Farewell.
division, so...
Farewell.